Okay, so this is our lecture 5.5, graphing cubed root functions. Yesterday we did square root functions. Now we're doing cube root functions. I understand the parent graphs for square root of x and cubed root of x. And I can graph transformed square root and cubed root functions and identify both the domain and range for both of those. Same exact essential standard. The cubed root function is another radical function. So in the past, our parent function, when we had the square root of x, now our parent function is equal to the cubed root of x. So we got to be familiar with what the cubed root of x looks like. Okay, this is the parent function. Here it is. There is this graph, so you can see this graph off to the right. It kind of goes through the 0 point and then curves off to the left. And we'll kind of talk about the table of data here in just a minute. And if you look at that graph, it has no values of x such that it is let's say it's undefined. So there is no restriction, all reals. The domain is all reals. Okay, you can see that because x goes from negative infinity all the way to positive infinity. And the same goes for the y values. This is also all reals. There are no range restrictions on this particular function as well. The normal parent function, it does go through the origin. So the intercepts, y-intercept is 0, x-intercept is 0. It has a symmetry about its origin. It's a point symmetry. And in behavior, as x goes to positive infinity, y goes to positive infinity, and x goes to negative infinity, y goes to negative infinity. It has this inflection point. So what is an inflection point? That's where the curvature changes. So if in fact, actually, it's right below here. The graph of a cube root has an inflection point. Inflection points are where the graph of the function changes curvature from curved up, concaved up, to curved down, concave down. So actually, curved up, this would be curved up, and curved down. This is curved down. So again, curved up would have this feature. So here's a curved up, and curved down would be something like this. So there's curved down, okay? This could even go even further. This is concave curved up. Okay. Unlike even radicals, odd radical functions do not have any domain constraints. So remember, if I ask you what the square root of 16 is, what we're asking for is what are two numbers, square root, that multiply by itself times 2 twice is equal to 16. So that's why 4 is equal to the square root of 16. If I ask you what the cubed root of 8 is, what number multiplied by itself 3 times is equal to 8? Well, that is 2. 2 times 2 times 2 is 8. If I had negative 8, I can have negative 2 as an answer because that will give me negative 8. It is an odd number, so we do not have the restraint or the constraint, sorry, that we do when we have even radicals of the value under the radical being above 0. It can be negative for an odd radical, so we don't have the domain constraints. Okay, one last thing. Just like we did in the past, when we had our parent function as square root of x, we should be able to quickly come up with this table of data so we know what the normal parent function looks like. We have to be able to do the same thing with our cubed root, okay? So if you think about it, what is 0 cubed? It's 0. What is 1 cubed? It's 1. What is 2 cubed? It's 8. What is 3 cubed? It's 27. We don't have a lot of values here that we have to work with, okay? Because if we're doing these manually, it's very unlikely that we're going to also include 27 on a graph, which would then be the cubed root of 27 is 3. And we could also have negative 27, okay? So you need to be familiar with 0 cubed, 1 cubed, 2 cubed, 3 cubed, and so forth. Okay, just like in the past, we have this parent function, and if we have these values a, b, h, or k, we can use transformations to be able to determine how that impacts our graph. So for example, a is outside of the parent rule, therefore it is a vertical dilation, okay? And if it was negative, it would be an x-axis reflection. The B value is inside the parent rule, and because of that, it is horizontal or a y-axis reflection. H is inside the parent rule, so it is horizontal or in the horizontal direction. So it's going to shift it right or left, which is horizontal. K is outside. It's going to shift it up or down, so that's vertical. Okay, so we're going to use this to again apply to our new parent function that we're learning, which is the cubed root. All right. Identify the transformation from the parent function and graph the parent function. We have to identify the transformation, we have to graph, and then we don't have to identify domain and range because it's all reals. But we do have to identify inflection point and the intervals on which it's curved up and curved down. So we have a couple things we have to do. So the first thing we need to do is identify the transformation. So I have this 2, it is outside, so it is vertical dilation of 2. So when we graph that, if I have x, if I had cubed root of x, and now I'm going to have 3 times the cubed root of x. So if it was, let's say, -8, that would have been -2. That's going to be -6. Then I'd have -1, and that would be -1. That would be -3. 0, 0, 0, 1, 1, 3, 8, 2, and 6. So this is the original parent function. This is what it would be if I multiplied times 3. Okay, I'm sorry, multiplied times 2. I apologize. Cubed. Now I got to go and fix all those quick, which is not bad. 2, that's -4, that's -2, that's 2, and that's 4. Okay. You're like, Ms. Aquaria, you lost your mind. All right, vertical dilation of 2. What else do we have here? We see we have a +1 under the radical. That is horizontal, so we are going to shift left 1, okay? So that is all we have, no reflections. All right, so now we got to graph it. So the original special spot was at 0, 0, but now I have to shift over 1. So I'm going to move it to -1. And I normally would have gone over, say, +1. Now I would have gone over 1, up 1. Now I'm going to go over 1, up 2. Normally I would have gone to the left 1, down 1, but this time I'm going to go to the left 1, down 2. Now we don't have enough room to go over 8. So these are the only points that we're going to worry about. And then we're going to get something that looks like that. And I'll get rid of this original point. So we now have to answer some questions. What is the inflection point? Well, the inflection point is located at -1, 0. Where is it curved up? This is where it's curved up. And so we have to answer that a little bit more specific than that. That will be from x equals -infinity, does not include, that's why it's a parentheses, not a bracket, all the way up until the inflection point, which is -1. The -1 is at the inflection point. You do not include it. This is the same as -infinity. No. X is greater than -infinity. And less than -1. And this is just in set notation. Okay, and then curved down. This would be curved down. So let's do that. And that goes from x, starts at -1 and goes all the way to +infinity. Okay. Okay, same thing, -1, x is greater than -1, and x is less than positive infinity. That's the same way to write that. I think that's all that they asked us for, so let's continue on. Why don't you try one yourself? Okay, welcome back. We have a reflection. It's outside the parent rule, which is vertical, so it is an x-axis. I have such a hard time writing that. An x-axis reflection. Okay. We have a -4 in the parent function. So before we apply the parent function, so that will be a horizontal, which is a shift right 4. We have a +2 outside, so that is in the vertical direction, so that is up 2. Okay. All right, so where did my original origin was here, and it would have normally looked something like this. But because I have an x-axis reflection, this will look something like this. Okay. Now let's get rid of, so it will look something like that, except now I have to shift right 4 and up 2. Well, there's where I'm going to start. And then I don't have a vertical dilation, so I'll go over 1, up 1, nope, over 1, down 1, because I have an x-axis reflection, left 1, up 1. I can actually get my 8. I have enough room to do my to the left 8. So 1, 2, 3, 4, 5, 6, 7, 8, and the cube root of 8 is 2. So I will have this point right here. I'm going to get rid of this green. Okay. All right. Now I can do this graph. I'm going to get something that looks like that and something that looks like that. Double check. Yep. Okay, inflection point. Inflection point is at 4. X is 4, Y is 2. Where does it curve up? This is the region in which it curves up. So that will be from X is equal to 4 all the way to positive infinity. Does not include 4. And it goes all the way to infinity. Where is it curving down? That would be that section. And that will be from negative infinity all the way to 4. And I believe that's where we're at. Okay. Again, get to the point where you can have x cubed root of x. So -8, -2, -1, -1, 0, 0, 1, 1, and 8, and 2. So, and then you can have your values determine what the vertical dilation is, and you can determine how to graph it. All right. Next one. I have a negative number before the parent rule. So that will be, that's a horizontal translation. So it is a y-axis reflection. And I have a +2. It's before the parent rule. So that is a shift left 2. +4 outside. So that is up 4. Up 4. And that's all we've got. So now we got to go and say, okay, here is my original graph. This is what it would have normally looked like. And now I have a y-axis reflection. So this will go that way. That will go that way. So I'm going to get rid of my red. And now I have to shift left 2 and up 4. So I start there. Let's start right there. Okay. And then, so normally I'd go over 1, up 1. I have to go over 1, down 1. I think I can go over 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, and I can go down 2. Instead of up 2, I go down 2 because of the reflection, and then I can only go left 1, up 1, and then I can draw this. There we go. And now I'll get rid of this. And so what do I got? My inflection point is at -2, 4. Where does it curve up? It curves up from x is -2 all the way to positive infinity. Where does it curve down? It curves down from negative infinity all the way to -2. And I think we've answered all the questions, right? Again, concaved up looks something like that. Concave down is something like that. And so this is approximately what portion of that would be for the concaved up on the graph that we're looking like. And it's in this region on the concave down, okay? All right, why don't you try one yourself? Okay, so welcome back. Hopefully it's starting to make sense. So we have a 3 outside, so it is a vertical dilation of 3. We have a -1 inside, so we shift right 1. We have a +2 outside, so we go up 2. Okay, no reflections. So again, get to the point where you have the ability to go, if it's the cubed root of x, this is my parent function, that would have been -2, -1, 0. I'm sorry, not -1. 1, 1, 8, 2. Now, we have to multiply the output that you normally would have got by 3. So now I have to take that value and multiply it times 3, cubed root of x. So if I would have normally gotten -2, I'm going to get -6. -1 will become -3. 0 is still 0, 1 is 3, 2 is 6. Okay. So now let's see if we can graph. So normally I would have my graph. It would look something like this, right? And so now I have to say, okay, I'm going to shift right 1, up 2, right 1, up 2. So now I'm going to start here. So normally I would have gone over 1, up 1, but now I'm going to go over 1, up 3. Normally I would have gone to the left 1, down 1, but now I'm going to go to the left 1, down 3. Now I think I can get pretty close on the left 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 puts me off approximately there. But if I would have had 8 to the left, I would have gone down 2, but now I'm going to go down 6. I'm just going to estimate where that is. 1, 2, 3, 4, 5, 6. That would put me right about there. So that gives me a target. So my graph would have done something like this and taken off that way. So now my inflection point is at x of 1, y of 2. Where am I curving up? All of these are curving up, that area right there. And so we start from negative infinity and go all the way up to 2. We don't include negative infinity and we don't include 2. Where am I curving down? We start from +2 and go all the way to positive infinity. Okay. All right, 2 more to go. Now we get to actually take a graph and create the equation. So what do they want us to do? They want us to identify the transformations and write an equation. Okay, so normally we would be at 0, 0, and it looks like I have shifted. I have gone right 4 and up it looks like I have gone up 1. Yes, up 1. It's actually not super easy to find exactly where that inflection point is, but it is up 1. Okay, you got to kind of be careful. You might think it's that point right there, but notice I still have quite a bit of straight line right there. Okay, so this is where the inflection point is. So up 1, right 4. I do not have a reflection. I'm still in kind of what I would have expected as far as shape. However, I am going over 1 and I have gone up 3. And I expected to have, if I had an x of 1, I would have expected the cube root of 1 to be 1. And so I had an output of 3. So I had to multiply my output by 3. So I have a vertical dilation of 3. Okay. So those are the 3 things. So now I've got to write my equation. And so f of x is equal to, so I have the cubed root of x. I've gone to the right 4, so I have to subtract 4 underneath the radical, and I've gone up 1, and I have a vertical dilation of 3. So here is my vertical dilation of 3. Here is my up 1, and here is my right 4. Okay, now let's try one yourself. Welcome back. All right, so normally this is what it would have looked like. I would have been off here and I would have gone this way, but notice I have flipped it. So we have a x-axis. You can actually call it an x or a y. It's easier to consider it an x-axis. Most people see that a little bit easier. X-axis, I flipped it, right? So x-axis reflection. Okay. Now, normally I would be here. I shifted left 1 and up 2. Okay. So now I'm here. And let's see if we have a vertical dilation. I expect to go over 1, up 1, and I did. And 1, 2, 3, 4, 5. I don't have enough space to check 8. So that is the only ones that I have. And so what is my new equation? X-axis reflection is a vertical translation, so it's outside, so it's negative. The cubed root of x, left 1 is plus 1, up 2 is plus 2 outside of the parent function. So here we go, x-axis reflection is right there. The left 1 is right here, and the up 2 is right here. And that is the answer. Okay, so for those of you who thought maybe it was a y-axis reflection, which is acceptable, that would just look something like this. Same thing, would have gotten the same answer. So, okay, have a great day and reach out to me if you have any questions.